All right, we're going to talk about and or. First of all, I just want you to recognize that there's going to be a difference between what is called the probability of a group, the probability of a group and another group, and the probability of a group or a group. So let's first talk about the and. This probability and we'll write mathematically with that upside down U. That says that it has to be in both groups, so both A and B are true. In a two-way table, we'll see it about here. That means this is true, that is true. On a Venn diagram, what we mean is that it has to be in both circles, so it's where they will overlap. Okay, the other guy is or, so go ahead and mark that. This is a union, okay, and it has to be in one or the other. So it could be in A and B, could be in just B, could be in just A, like this. In a Venn diagram, that includes both sections of what we're talking about. One way we could think about it is that this is giving this guy a hug. We could think of it like that. Oh, and the other thing I want to mark or note is that this right here, this little mark isn't a typo. He means not. So that means not whatever A was, okay? This means not whatever B was. Same thing over here. Okay, so first, we're going to talk about Freddy's Fish Shack. What we see is that they serve fish or chicken. So one of these circles needs to be marked fish or chicken. I'm going to mark him fish. And the other circle deals with being fried or grilled. I'm going to mark this as fried. That's an F. There we go. So let's finish up some of our information here. It says he collects some data and found that 45% of his customers ordered fish. So in this circle, we need 45 total, but specifically it says 15 of them were fried. So the ones that are in both of them will go in this space, and then 45 minus 15, which is 30, will go in this space right there. All right, so now what we're going to do is look at the other pieces of information. For example, he said he found that 35% of all dishes served were fried. So 35 needs to be in this circle. And if I take out 15, what I'm left with is 20% in this section right here. Okay, so who didn't we account for? Well, we didn't account for those who are chicken, meaning not fish, and those who are grilled, meaning not fried. So out of 100% of the people, we're going to take out 30%, that's 70. We're going to take out 20%, that's 50, and we're going to take out 15%, which leaves me with 35. So 35% would be considered chicken and grilled. All right, and now we're going to attack that using our Venn diagram and how all of this is related. So the probability of being a fish dish, so fish was all of this bit right here, is going to be 30 and 15% together. So that's the 45%. Now down here, they're talking about fried and fish. So I want you to recognize it has to be in both circles, and that would be 15%. So 15%, I guess I'm using my highlighter for that. Then, oh, and I wanted to mark the center. Oop, has to be in both groups. D says that it's fish and grilled. Whoops, I read that backwards, but grilled and fish. So grilled happened over here in this part of that circle. Whoops, not grilled. Grilled happened in this part right here, and fish, meaning he's in that spot with, wow, right there. There he goes. Grilled and fish section. So that would be my 30%. Oh, let's do this one. Fried and chicken. So in my fried circle, not fish stuff, but fried stuff would be this 20% right here. All right. Then we have grilled grilled or fried. Now in this case, grilled or fried, fried is this whole circle, and grilled is everybody who was in here and outside of here. So I just want you to recognize that would be the 30%, the 15%, the 20, with the 35. That's 100% of the folks that are grilled or fried. I want to add one more. We'll get to this one in just a second, but I want to add one more. What if he is grilled or fish? Well, that would take care of this circle right here, and it would take care of everybody who is, so fish takes care of my fish. Then it takes care of not this part, not the fried part, okay, but it does take care of anybody who's outside of the fried part. If that makes sense. Okay, and then the last we have not fried fish. So that would be everybody not in the middle there. And so that would be 100 minus 15 would be 85%. Okay, so there is this on your notes. I would like you to pause the video and read that through. It talks about tuberculosis, what it is, but what we're going to do, so pause the video, give yourself about 3 minutes to read. And what we're going to do is apply that here to this table. Okay, so what I want you to recognize is that when you get tested for tuberculosis, there is going to be a slim chance that you're going to have that tuberculosis but tested negative. That's what that means. Okay. We're going to have another chance that you didn't have tuberculosis but you still test positive. That's what that group is. Okay. We have a group that had tuberculosis and tested positive. But for the most part, and this is good, people didn't have tuberculosis. There we go. And they tested negative. So these are what we've got. We've got our tuberculosis and those who don't have tuberculosis. We're going to use our new thing here. Okay, we have those who tested positive and those who tested negative, like this. So those who had tuberculosis, so in this group, but tested negative would be here. And for us, that was 19 out of everybody. Okay, then we have a group, this purple group, that didn't have tuberculosis, so no, but they tested positive. So that would be right here. We're going to make that the 62. This was my purple stuff. Okay. We have a green section that had tuberculosis, so yes, but they tested positive. And so that would be 361. And then we have another group who didn't have tuberculosis, yay, and they tested negative. That was 558 of the folks. All right, so finishing this up, all of our data, if I add this way, so 361 and 19, I get 380. If I add this way, I get 620. This total is 423, and this total would be 577, and that makes up all 1,000 patients that were tested or checked for tuberculosis. If I add these up, I get 1,000. If I add these up, I get 1,000. Okay, so I'm going to put this off to the side, be near. So here's my table, redone again. And what we're going to find, we're going to walk ourselves through finding these percents in here. Where'd my thing go? Oh, here it is. Found it. All right. So what we have, they're going to ask us what percent is of the sample is infected with tuberculosis. And what I found is, first of all, I need to know those who, of all the sample, were found with tuberculosis. So that would be 380 out of 1,000. And if I put that in my calculator and divide, I get 0.38. I times by 100, and that gets me 38%. So 38% of the people were infected with tuberculosis. Okay, what percentage then was told that they have a positive test result? Well, my positive test result is 423 here out of 1,000. So I take my 423, divide by 1,000. That gets me 0.423. When I times by 100, that is 42.3%. Okay, part C then says, compare your answers A and B. So these are the people who had tuberculosis. These are the people whose test said they had tuberculosis. How accurate is the test? Well, this is where my thoughts are. 42.3% said they had it. 38% said, like, really had it. And that means we have a change of 4.3%. That is a pretty low percentage of a mistake, a difference. And so I'm going to say that this is pretty accurate. Perfect? No, but pretty accurate, yeah. We want to know who is sick so we can help them. Okay, last, or not last, but next we have what percent of people tested were given a correct result? Well, let's look. They had tuberculosis here, and they tested positive, so that's my 361. And those who didn't have it and tested negative, that's 558 out of 1,000. That's not too bad. What that says is that 919 out of 1,000 folks had the correct result. And so if I take 919 and divide by 1,000, that gives me 0.919, and I times by 100, that gets me 91.9%. The tests were 91.9% accurate, which is pretty good. That's a high percentage. As a percent, then, we're just going to kind of explore a little bit more. As a percent, what is, that's probability negative first. So of those who tested negative, that would be 577. Who did have tuberculosis, well, that's only 19 who, whoops, I mean to say that was the 558 because they, okay, who had a negative result, yep, has tuberculosis, oh, that's 19. Okay, so then I do 19 divided by 577, and that gets me 0.320. When I times that by 100, that's 3.29%. There we go. That has what's called a false negative, meaning it was an incorrect test. Of those who didn't actually have tuberculosis, so let's look with gray. Okay, so those who don't actually have tuberculosis, so didn't have, that's 620. What percent tested positive? So didn't have, but they tested positive, that would be 62. When I divide that, that gets me 0.1, or I could multiply that by 100, and that says 10% of the people had a false positive. So it was inaccurate about that many times when we had to look just at those percent who tested positive.